So only two topic is remaining from this chapter, which we are going to cover. One is homologous series, and the second one is functional group. Okay. Rest of the part we have covered. Now you might feel like why we are not discussing question number 4 right now. I mean, right now means in this particular time. The reason is because it is related to the content of homologous series and functional group, and I don't feel that we should jump up to any question without knowing what is the basic idea behind it, right? Just for the sake of completion of assignment. So what we will do is we will first understand what do we mean by homologous series and functional group, and then we will discuss question number 4. Is that okay? Right? And question number 5, it is related to naming, so this is already deleted from your portion. It is okay if you don't do question number 5 because it is related to nomenclature part, which is no longer a part of your syllabus. Yeah, that is one thing. So let's move to the next topic, which is homologous and functional groups. So any of the hydrogen atoms in a hydrocarbon can be replaced by atoms or group of other atoms, elements. You have seen methane, right? CH4. All the atoms which were attached to that carbon were hydrogen only. That is why we were calling it as hydrocarbon, because it is composed of hydrogen and carbon. But it is not always necessary. I can replace one of the hydrogen or two of the hydrogen or three of the hydrogen or even four of the hydrogen with some different elements like oxygen, chlorine, fluorine. That is possible. Carbon easily forms bond with other elements such as halogens like your fluorine, chlorine, bromine, iodine, oxygen, sulfur, and nitrogen. The element replacing hydrogen is referred to as heteroatom. Hetero means different. Okay. So just to give you an idea what I am talking about is, till now we have only seen simple carbon and hydrogen molecule, and we were not concerned with the other elements, whatever we have covered under alkanes. We were talking about CH4, we were talking about C4H10, we were talking about C5H12 and things like that. So only two element was present. Now don't focus on the number. Only two elements were present. One was carbon, one was hydrogen, carbon, hydrogen, carbon and hydrogen. Now we can replace one of the hydrogen with some other element. So if this is your methane, CH4, like this, I can replace this hydrogen with chlorine. Not, in that case, if I am replacing, then it no longer remains methane. That is correct. If you will tell ki ma'am, I will replace one hydrogen with chlorine, that will not be a methane. Absolutely correct. It will not be a methane, and it will also change its properties, because you are replacing hydrogen with some different element like chlorine, and chlorine has altogether a different property. It belongs to 17th group, halogen family. I can write it like this also: chlorine, 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 chlorine. I have replaced all the four atoms of methane with chlorine. That is also possible. So this is known as chloromethane, tetrachloromethane, something like that. Okay, so this is possible. So when we are replacing hydrogen or one of the hydrogen or two of the hydrogen with some different element, we call that element as heteroatom. Hetero means different. Homo means same. Okay, your school uniform is same for each and every one of you. So that is because homogeneous nature. But if it is different, then it is heterogeneity that arises. Okay. Is this clear, the definition of heteroatom? So any of the hydrogen atoms in a hydrocarbon can be replaced by other element like this we have discussed. Okay. So we will move to the textbook now. Now this heteroatom and the group containing these confer specific properties to the compound. That is what I explained you, that when you are calling CH4 as methane, and if you replace one of the hydrogen of methane with chlorine, will that compound show the same property? I mean, are these two same in terms of reactivity, in terms of chemical property, physical property also, let's say boiling point, melting point? No, they are not the same. So they are trying to tell you is that whenever you replace hydrogen atom with any of the heteroatom, this heteroatom is altogether going to change its property. Okay, altogether it's going to change its chemical property, physical property, etc. I don't remember, but I have told you this thing about functional groups when we were doing the experiment related to the properties of acetic acid, ethanoic acid, where we discussed this term, what is known as functional group. So just to give you a basic idea over there, I have related the functional group concept with your surnames, if you remember, that you people have a unique surname that defines your property, okay, from which maybe caste, religion, whatever it is you come from, so that is characteristic of your family, right? Similarly, under the class of chemical compounds, you have these heteroatoms, like you can see chlorine, bromine, and all these things. If you attach these heteroatom to any of the carbon molecule, to any of the hydrocarbon, they are going to altogether change that functionality. Functionality means its chemical property, physical property, etc. Regardless of the length and nature of the carbon chain. Okay, doesn't matter your carbon contain 4 number, 5 number, 6 number, but when you are going to replace it with all these compounds now, it is going to change it altogether. Okay, so for functional group, if you are sitting with a rough notebook, it would be better because I'm going to give you that chart. So the first functional group that we are going to discuss is of alcohols. Functional group, you understood now. These are basically those heteroatoms which when get attached to the main hydrocarbon chain altogether changes their properties, chemical and physical. The structure of alcohol is OH. What does this means? This means a carbon chain which is continuing. I don't know. That carbon chain can be of 4 carbon, it could be of 5 carbon, 6 carbon, 7 carbon, I don't know the number. So we draw it like this. Depends upon you. But if I am talking about methanol, ethanol, propanol, butanol, whatever alcohol I am going to talk about, it should contain this OH functionality. And the name in that case will end with the suffix ol. So if it is methane, see, this is your methane, CH4, yes or no? Yes. If I replace this hydrogen with, let's say, OH, so what will be the structure looking like? CH3, because this I have not removed. This hydrogen I have removed now. So I have removed this hydrogen with a heteroatom called as OH. Now this is my methane. Is this a methane molecule? The second one which we have drawn by replacing it with OH. Is it a methane? Yes? No, it is not a methane. Now you know that OH is attached. That means it's an alcohol. Alcohol always have the suffix ol. So this is called as methanol. So when you have this suffix ol, that means it's an alcohol. It contains OH group. Okay. OH group, if I want to further segregate it, it is like this. There is a single bond that exists between oxygen and hydrogen, to be more precise. But we write it all together. If you want, you can show it in this way also. This is not wrong. Now this is 2 carbon compound, right? 1, 2. When there is 2 carbon, the root word is ith. Now this is an alkane because I don't see a double bond over here, right? Yes, Sanskriti. Done? Okay. Yes. So whenever there is 2 carbon, we call the root word that we use is ith. Okay, like you have root words in English, same way over here. So the root word is ith. Now this is an alkane, alkene or alkyne. Yes, what it is? Alkane, alkene or alkyne? Alkane. And in alkane, what is the suffix that we add to the end? Ane. So this is ethane. Okay. Now what I will do is I will replace one of the hydrogen with OH functionality. So again 2 carbon, and now I will replace it with OH. These are again hydrogen which I have not replaced. Now tell me the name. Myth means one carbon. Arhan, whenever you have this root word myth means one carbon. Eth means two carbon. Yes, it is ethanol. So again, two carbon. So the root word is eth. And OH, that means it's an alcohol. So the suffix is ol, OL. So ethanol. So I hope you got a basic idea. I've tried to correlate nomenclature part also in the functional group. Okay, shall we move to the next set of functional group? Yes, everyone? Okay. So the next functional group is carboxylic acid. This is how we represent a carboxylic acid. Carbon, double bond with oxygen, then single bond with OH. Now you may argue that what is this? This is again a carbon chain. You can add number of OH, Shreya. Just this was just to Satyajit, sorry. You can add number of that. Not a problem. I explained you just to give you an example. How do we do the naming and all? Okay, Satyajit. You can add 2 also, you can add 3 also. This is O, oxygen, not a dot. Yeah, so this carbon has formed double bond with oxygen and single bond with OH. Okay, and there is a single bond that exists between this OH. What is this? This is a carbon chain that is existing. Why I have drawn it like this? Because I don't know. It could be one carbon chain if it has to be a methanoic acid, myth. If it has to be a ethanoic acid, there will be two carbons. So I don't know the number. That is why we draw it like this. The chain is extending. That is the meaning. And the suffix that we use is oic acid. OIC, oic acid. Okay. Yeah, the valency should be satisfied. That is very, very important. 1, 2, 3, 4. So each carbon is now also forming 4 bonds. Don't disturb the bonds. 4 bond means 4 bond. Okay, now again, this is your methane, CH4. If I have to replace it with this heteroatom, which is also carboxylic acid, what I will do? See, there has to be only one carbon. So carbon, double bond, O, then OH. Now, how many hydrogens can I draw? Because 3 bonds are already there. Can I draw these 3 hydrogens? Is this carbon having that much valency now? Because it has already formed 2 and 3. No, so I can draw only 1. This is your methane because it has 1 carbon. Yes, Anuja, sorry, Urvi. This is 1 carbon. Yeah, so 1 carbon means the root word is meth. What is the suffix? Oic acid. So it is methanoic acid. Don't just see it from that point ki ma'am has said that if it is a double bond, it is ene and then it will be methene. Methane is not existing. I have told you methane cannot exist, and altogether you have a heteroatom now. That is oxygen, which we didn't discuss right from first, second, and third period, which whatever we have covered for carbon and its compound. Okay. No, no, no. It is methanoic acid. Methanolic, nahi, methanoic. You can take that, Urvi. Okay. The third one is aldehyde. This is how we represent an aldehyde. C double bond O and H. If you see the difference between carboxylic acid and aldehyde, you don't have OH over here. You have a simple hydrogen. Ending is al, Al. So this is your methane, CH4, CH4. Again, I will draw 1 carbon. If I have to draw aldehyde, I have to draw this structure first. Now, can I draw 3 hydrogens again over here? For this, no, because already it has formed 3 bonds. So I can draw 1 more hydrogen. That is what I can do. Okay. Now what it will be? Correct, Shreya. Very good. So you are getting it now. So 1 carbon means myth. That myth means the root word. And it ends with al. I mean aldehyde ends with al. So it is methanol. So you should be able to identify the functional group. Huh? This is the functional group. and you should be able to your brain should be able to tell you that this functional group is of aldehyde. You may see that what is this? This is a carbon chain or hydrogen chain. So you can see this chain over here, hydrogen chain or whatever it is. This is aldehyde that ends with al. Next one is ketone. You have major 4 or 5 functional groups also, but that is not the end of chemistry. This is the structure, ketone. So you have a carbon chain on this side, you have a carbon chain on this side, and in the middle of the carbon chain you have C double bond O. Okay, the ending should be on, O-N-E. So this is your methane, CH4, right? Now what I will do, if I want to substitute or if I want to add this heteroatom, again I will need 1 carbon. Okay, then double bond O. Yes. So what will be the name now? Methanol. Yeah. You can draw it for ethane also. No. Sorry. Yeah. Just a mistake over here. Why can't we call it as ketone? The reason is because this functional group which is present now, C double bond O, this always has to be in the middle of the carbon chain. Sorry for that. It is not methanol. The reason why I am explaining you, please listen it very, very carefully. If you see, this is a functional group of aldehyde, C double bond OH, not ketone. Yes, this is what you have drawn for aldehyde, na? C double bond OH. Aldehydes are always present at the terminal carbon. So that is the difference between aldehyde and ketone. Ketone doesn't have H. See, there are no hydrogen. Aldehyde has H. It is always present in the terminal position. For ketone, it is always present in the middle chain. I'll tell you. Wait. 1, 2, 3. These are the hydrogens like this. What is this compound also known as? If you have 3 carbon, the root word is prop, and because it is an alkane, no, butane means 4 carbon. Okay, so this is propane. Okay, so if I want to draw ketone, 1, 2, 3, and then I will place this oxygen in the middle. Ketone will always come in the middle of the carbon chain, not in the terminal. If it is coming in the terminal, then please be careful, very, very careful. It will no longer be a ketone. It will be an aldehyde. Okay, so this is CH3. Okay, now tell me the name. Again, there are 3 carbon. So the name is propanon. Okay, O-N-E. The o suffix should be propanon. Clear? Please be very, very careful. Ketone will always come in the middle of the carbon chain. Aldehyde will always be in the terminal position. Terminal means end में होगा वो. Carboxylic acid we have done. Ketone, aldehyde is done. Next is homologous series. First of all, tell me, functional group is clear or not? Otherwise, we can't move ahead. Yes, okay. So just practice it, drawing and all. Homologous series is basically a family of compounds where they have all members. Yes, Ullas, I'll show. You can't draw it for 2 carbon also, huh? Because for 2 carbon you can't find the middle. It is all for 3 carbon you can have a middle placement. That is why I've started with 3. Okay, so homologous series is basically a family of compounds where it has the members. Okay, just like you have a family which comprises of you, your brothers and sisters, your father, mother, and even if it is a joint family, then there is going to be more number of members. So homologous series exist for all the compounds. So you have alkane family, You have alkene family, you have alkyne family, then there's a different family for alcohols, aldehydes, ketones, whatever functional group you have studied. To make it very, very simple, I will take the example of alkane. What is the first alkane that you have studied? Simplest alkane, one carbon compound alkane. Yes, the general formula is CnH2n plus 2. This we have already discussed. Now tell me, the first member of alkane will be CH4. Okay. Second member of alkane will be a two carbon compound. So what will be the formula? C2H6. Third member C3H8 and so on. This process will go on from 10, 11, 12, 13. It will never end. Okay. So I will just explain you using three of the member. These three compounds belong to the same family of alkanes. Why? Because they are fulfilling this general formula of CnH2n plus 2. They also contain same elements C and H. Yes, the number are different, I do agree, but the elements are same. Now understand the properties of the members of homologous series. The two adjacent member of homologous series always differs by CH2 unit. Adjacent members are don't think if we will take first and third. No, first and second or second and third. It has to be adjacent. See, this is 2 carbon, this is 1 carbon. So 2 minus 1 is 1, therefore 1 carbon. There are 6 hydrogen, there are 4 hydrogen. 6 minus 4 is 2. So that is why I am telling that between two adjacent member of a homologous family, there is a difference of CH2 unit. Yes, that is same like that. If you count it for even second and third, provided it has to be adjacent, again the difference will be of CH2 unit. You can judge it. There is 3 carbon, there is 2 carbon. 3 minus 2 is 1. So 1 over here. There are 8 hydrogens, there are 6 hydrogen. 8 minus 6 is 2. So CH2 unit. So between every adjacent members now, I have taken the example of alkene. Alkane. You can take it for alkene, you can take it for alkyne, alcohol. Every time the difference will be same of CH2 units. Okay. Or in textbook they also write it as 14U. The difference is of 14U. How can anyone tell? Yes, good. 14 is 12 of carbon plus 2 of hydrogen. That is how 14 is coming. So you can write it in terms of CH2 unit or you can write it in terms of mass, 14U. Okay. And as you move ahead in the homologous family member, like you are going from 1 carbon to 2 carbon, then to 3 carbon, 4 carbon and 5 carbon, can you see the number of carbon is increasing when you are moving from 1 to 2, 2 to 3, 3 to 4? Yes, for homologous series member, you can you see there is a increased trend when you are moving from methane to ethane to propane 3 carbon to butane for 4 carbon, pentane 5 carbon. So what is happening now when you go down and the number of carbon increases, the physical properties also increases. Obviously, methane is 1 carbon, ethane is 2 carbon. Whose physical property should be higher if I talk about melting and boiling points? किसकी ज्यादा होनी चाहिए? 2 कार्बन कंपाउंड की ज्यादा होनी चाहिए या it should be of 1 carbon compound? For breaking the bonds, you will need energy, right? So you will need energy for 1 carbon or for 2 carbon? Yes, you will need it for 2 carbon. So as you move down and the number of carbon is increasing for a member, the physical property also increases like melting and boiling point. So these are the three different properties that we have discussed. Okay. So with this, we have come to an end of this chapter. I'll quickly discuss the in-text question that was remaining. Rest of the portion is deleted, so don't worry about it. Now you have to draw the structure. Ethanoic acid. Eth means how many carbon? Yes, we have discussed it. If the root word is eth, how many carbons are there? 2 carbon. First of all, you have to draw the structure of ethanoic acid now. Now it is an acid, oic acid, so you should know the functional group first. This is how the functional group of carboxylic acid. It is it. So 2 carbons. So what I am going to do, first I'll draw the 2 carbons. Now if I have to make it as an acid, I have to draw this structure also. You may think कि मैम हम यहाँ पे एक कार्बन और ऐड कर देते हैं और ऐसे बना देते हैं. Now will it remain ethanoic acid? How many carbons are there? 3 carbons. So that means you can't do it like this. So whatever carbons are existing, on that only you have to draw. So now you can draw the remaining hydrogen. So this is how the structure of ethanoic acid looks like. CH3, C double bond O, OH. Yes, is this clear? Okay. Butanone. Can you draw for butanone? First tell me the functional group of butanone. ONE is the ending word of which functional group? Ketone. Very good. So for ketone, this is the functional group now, and this this is to be like this always comes in the middle of the carbon chain. So you have to draw for butanone. But means how many carbon? Yes, but means how many carbon? No, 2 is for it. Yes, so 4 carbon, 1, 2, 3, 4. Now this is there in the middle, or it can be at second carbon or third carbon, depending it will change. So you can draw it over here also, or if you want, you can detach it from this position and can draw here also, not a problem. And remaining, you can satisfy the valencies. Why I have not drawn hydrogen over here? Because this carbon has already made 4 bonds. That is why. Okay, so will you be able to draw the structures now? It is hexanal. Al is the is the suffix for aldehyde. So aldehyde, you have to draw this, and it is hex. That means there has to be 6 carbons. Okay, bromopentane. Bromo means which heteroatom? Bromine. So you have to draw pentane first. Pentane means 5 carbon, and replace one of the hydrogen of those 5 carbons. Like this is pentane. You can replace one of the hydrogen with bromine, and rest you can make hydrogen. So this is your bromopentane. Okay, is this clear? Yes, always the total number of carbons including the functional group should remain same. Okay, so with this we have completed our chapter carbon and its compound. I hope it was clear, but if you will do practice from your side, it will be more clear to you.
If you like our videos, do share them and subscribe to our channel. If you want awesome quizzes, write to us. Keep watching and keep learning with Walnut.